We're going to take our probability a step further, and we're going to start looking at the idea of the difference between combinations, permutations, and then their applications to probability. A lot of people have heard these terms before, but they might think they're the same. But in fact, there is a subtle difference between the two. And it has to do with arrangement of the objects. And I'll talk a little bit about that in a moment. So whenever you select objects, and if you flip the objects around, you produce a new order. That's called a permutation. So a permutation is a way of arranging elements in a set such that the order that they are arranged is important. If you flip those around, you're going to get a new permutation, right? And then the other type is the combination. And a combination basically says that if you do flip the objects around, that you're not going to get a new permutation or a new, if you flip them around, you're not going to get a new combination. So that's important. All right, so just as an example, as the difference between a combination and a permutation. Let's say for some reason that you are on some sort of committee or something like that, and what you're doing is you're holding three positions. So let's say there's a president, a vice president, and then a secretary. All right, and let's say there's three people. All right, so let's say there's Jane, and let's say there's Jack, and let's say there's Jesse. All right. And what we would do is we would say, okay, well, if we have three people, this is one permutation. Okay. But let's say I flip around Jack and Jesse. All right. So let's say Jack and let's say Jesse decided that they're going to flip around their positions. Right? So now Jesse's the VP and Jack is now the secretary. All right, so that's another permutation, all right, because the order in which they select the positions is important. Let's say for some reason that Jane and Jack flip. All right, so let's say Jane doesn't want to be the president anymore and Jack does. Okay, that's another permutation. All right, so permutation basically means that the order in which they are set up is important. All right, now an example of a combination. Let's say for some reason that these three folks are again on a committee, but it doesn't necessarily matter what their positions are. In other words, there's no positions, there's no president or anything. Okay, so there's just something like, you know, person one, person two, and then person three that's on the committee. Okay, so there's no sorts of designated positions. And again, we have Jane is person one, Jack is person two, and Jesse is person three. All right, and they all serve on the committee. All right, so maybe for some reason they all do the same job at their store. All right, and let's say for some reason, like maybe these are just register lanes or something like that, like they work at a grocery store. Well, let's say for some reason that Jesse and Jack decide to flip around. Okay, so it's still the same combination. Okay, so it's only one combination. And if they flip around, let's say we flip around Jane and Jesse, and again, these positions hold no order. Right? So now maybe Jesse is in lane one or person one, and then Jane. All right, it's still the same combination no matter what. All right, so combination basically means that no matter how we flip around the elements, as long as we select those three elements, we're still going to have the same elements. All right, because the positions don't hold any significance. So just some examples, if I give you a list of items as to how to pull out combinations and permutations, might be a good idea just to get an idea of these animals. So let's say for some reason we have a set S, and the set S has the elements A, B, C, D. The first thing I'd like to do is I'd like to list all permutations of 2 in the set S. All right, so that means what we're going to do is we're going to pull out 2 elements. Right? So one is obviously going to be AB. Right? Another one is going to be AC, and then a third is going to be AD. So all I did here was I just started here with A, and then I pulled them out. Right? Now, I'm going to do the exact same thing. I'm going to start with B this time, and I'm going to have, this is just my way of keeping the order, so that way I don't miss anything. So I'm going to have BC and BD, and then finally I have CD, and those are the only 6 that I can pull out so far. All right, so CD. So again, notice what I did was I started with A, and then I just went AB, AC, AD. Right? And then once I was done with A, I didn't use A ever again in selecting the first round. And then finally, what I can do is I can say not AD, CD, excuse me. All right, so now, that's not all the permutations, all right? Because remember what we said with a permutation, if I flip the order, okay, these are not the same, right? So in a permutation, AB, so remember we had that example where Jane was the president and then Jack was the vice president. If I flip those around, it's not equal. This is not equal to CA. This is not equal to DA, etc. So what we're saying is that there are 12 total permutations. So hopefully that makes sense, okay, as to how to try to pick through the order of those. Now for part B, it's saying to list all the combinations, right? So we're going to do the exact same thing as we just did. So we're going to say AB, and then AC, and then AD. Right? So notice we have that trick we just keep doing. And then we're going to start with B this time. So BC, BD. And then finally, we have CD. Now, with a combination, the order is not important. So if I flip those around, these are the same. So it's only one combination. And CA is the second combination. And DA, which is the same as AD, is the third combination. Excuse me. And notice that as we flip these around, they are the same. All right, so in a permutation, when you flip the order, you get a new permutation. When you flip the order of a combination, you do not get a new combination. All right, so there's only 6 of those. All right, now, what if instead of 2, we were asked to select 3 elements from the set? Right, so for part C, we're going to have to list all the permutations of 3. All right, so this is where it gets a little bit more painful. So now we're picking 3. So we have A, B, C. This is for part C. And then we have A, B, D. All right. And then we can also have A, C, B. I'm sorry, A, C, D. All right. And then finally, the last one we have, we've already exhausted all the possible A's. So notice we had A, B, C, A, B, D, A, C, D. All right, again, these are all 3s. And the last one that we could have is going to be B, A, C. Now, what we have to do is we have to flip all of those around. All right, so another permutation would be A, C, B. Or B, I'm sorry, going back here, this should be B, BCD, sorry. All right, so we didn't want to use A in that one, I apologize. Okay. So going back here, we have ACB, and then we have BAC is another one. We have BCA, and then CAB, and then CBA. All right, so notice that all we did was we just flipped around all the different possible permutations of this. All right, so notice all the orders are different. We're going to do the same thing over here. So we have A, D, B. And notice what I try to do is I try to keep the first letter the same as I'm doing this. All right, so that kind of helps me keep things in order so that way I don't accidentally miss one. So this is going to be, I've already exhausted the two A's, so B, D, A, and B, A, D. And then finally, let's use the D. So there's two D's in this. So we have D, B, A, and then D, A, B. And now we can do the same thing over here, ADC, and then CDA, CAD. And then we can start with D, so DAC, and then DCA. And then finally over here, we have another B. And then we have, let's start with a C, D, B, and CBD. And then we can start with D, so D, BC, and DCB. All right, so notice that there are 24 of these. All right. Imagine how difficult this would be if we started boosting up the number of elements in the set S to like 5 or 10 or 15 or something like that. We might be literally here all day trying to figure out the number and also the ordering of the observations. Now, fortunately for us, part D is a lot easier. So remember what we did initially when we picked A, B, C, and A, B, D, and A, C, D, and then B, C, D? So remember we had A, B, C, which was this one, and then we had A, B, D, which was this one, and then we had A, C, D, which was this one, and then B, C, D, which was this selection. All right. Everything else under here, these are all equal for permutation or for combination, excuse me. All right, so these are all the same combinations. So fortunately, once you write those down, then you're done. You don't have to write down any other different orderings because they're all going to be the same combination. So there's only 4 combinations of 3. Right? And that's what we're going to take a look at in the next video, is just figuring out how many different numbers of orderings there's going to be. Because a lot of times the orderings, the number of orderings, is more important than what the numberings actually look like. Right? But this is essentially what a combination and a permutation are, and these are how we try to go through and figure out what those combinations and permutations look like.